The freezing reason your blood carries the same mineral signature as the Atacama's forbidden underground rivers. And in 2019, a drilling crew broke through 2 feet of desert crust and found something that looked exactly like it was bleeding. Your body is doing something right now, something the Atacama has been doing for 3 million years, and scientists only just figured out what it means. The Atacama Desert in northern Chile is the driest non-polar place on Earth. Some weather stations there have never recorded rainfall. Not once, not ever. But researchers found something seeping through that bone-dry crust. Red, cold, moving. They called it a cryogenic brine, liquid so saturated with salt and iron that it stays fluid at -20 degrees Celsius. Water that shouldn't exist in a desert. Water that looks under a headlamp exactly like blood. And here's what no one is saying out loud yet. The chemistry of what they pulled from that ground matches something circulating inside you right now. Iron, that's the connection. Your hemoglobin, the molecule that makes your blood red, carries iron atoms at its core, 1 per molecule, billions per drop. That iron is what captures oxygen in your lungs and hauls it to every cell in your body. Without it, your tissues suffocate from the inside. The Atacama brine is red for the same reason. Ferric iron, oxidized and suspended in a hypersaline solution so cold and so chemically hostile that almost nothing survives in it. Almost. In 2019, a team from the Universidad Católica del Norte collected samples from a site called Punta Negra, a salt flat at 3,400 meters elevation where temperatures drop to lethal at night. What they extracted from the crust wasn't dry. It was viscous. It was red. And when they ran it through a mass spectrometer, the iron concentration was 400 times higher than normal groundwater. 400 times. The Atacama has been concentrating that mineral for longer than our species has existed. Here's where it gets strange. Cryogenic brines aren't supposed to move. That's the whole point. They're locked in crystal matrices, frozen but not frozen, suspended in a kind of geological stasis. The salt lowers the freezing point so far below zero that the brine stays liquid, but barely. It should be sitting still. It wasn't sitting still. The 2023 follow-up study, the one the headlines missed, found these brines flowing, not pooling, not seeping, flowing through subsurface channels, carving their own micronetwork through rock that had been geologically dead for 2 million years. The desert was circulating something, like a heartbeat. That image is not a metaphor. The researchers used it themselves. Here's what scientists spent 4 years quietly figuring out. The Atacama sits on top of one of the most tectonically active regions on the planet. The Nazca Plate is diving beneath the South American plate at 77 millimeters per year, faster than your fingernail grows. That subduction generates heat, not enough to melt the surface, but enough to create thermal gradients dozens of meters underground. Those gradients are pumping the brine. Heat rises from below. Cold descends from the night sky above. In the Atacama, nighttime temperatures at elevation crash to -15 within an hour of sunset. That thermal difference creates a convection loop. The red brine cycles. It rises, cools slightly, sinks, warms, rises again. But here's the part that genuinely unsettled the research team. Those brines aren't sterile. Microbial communities, extremophiles so adapted to the cold, the salt, and the iron that they exist nowhere else on Earth, were found living inside the flow. Not on the edges. Inside, metabolizing iron, exhaling sulfur compounds, thriving in a liquid that would kill everything you've ever touched. They have no business being alive. And yet the Atacama has been keeping them alive, cycling them through that red underground current for an estimated 200,000 years. A hidden biosphere, running on iron, in the driest place on Earth. Your blood has been doing something similar for 300,000 years of human evolution. What does that mean for us? NASA's Astrobiology Institute flagged the 2023 findings within 6 weeks of publication. The Atacama has become the primary analog site for subsurface Mars research, because Mars has the same combination: extreme cold, iron-rich geology, ancient salt deposits, and subsurface thermal activity from remnant volcanic heat. If life can circulate through red iron brine 3,400 meters up in a desert that gets no rain, then the question isn't whether Mars ever had life. The question is whether something is still cycling beneath its crust right now. And if there is, it wouldn't look like us. It wouldn't need oxygen or sunlight or liquid water as we define it. It would look like what they pulled out of the Atacama. Red, cold, moving against every rule we thought applied. But here's the question the research team published last and buried deepest. The thermal convection loop driving the brine, it's accelerating. Measurements from 2019 to 2023 show a 14% increase in cycle rate. Something is changing in the heat gradient below the Atacama. They don't know what. A desert that hasn't changed in 2 million years is suddenly speeding up. And whatever it's pumping through that red underground river, it's moving faster than it used to.